Hello friends, in trick 11 we studied how we remember some of the algebraic identities like a plus b whole square, a minus b whole square, a plus b whole cube and a minus b whole cube. Let me just take a little glimpse of that. I told you when we have to write the expansion of a plus b whole square, then we start from a square, reduce the power of a, and in the third term there is no a. For b, we start from here b square, reduce as we go towards left, and there will not be any b here. And for the coefficients, I told you that we use the Pascal's triangle. This was the Pascal's triangle which we dealt with in trick number 11. So here we have three terms. So the coefficients of the three terms are 1, 2 and 1. 1, 2 and 1. So we have a positive sign in between here. So we write all the positive signs. Similarly, if you have a plus b whole cube, then we start from a cube because the highest power is 3. Then reduce the power of a by 1 further, and a vanishes in the last term. B cube starts from the last term and the power goes on decreasing as we move towards the left. There is no b in the first term. For the coefficients, we refer to the Pascal triangle. 4 terms, 1, 3, 3, 1. So 1, 3, 3 and 1. And in between this we have this positive sign. So all terms will be positive. Using this expansion, you can write expansions of terms which have a higher power also. Like you expand this Pascal's triangle, next row will be this, next row will be this. This row contains 1, 2, 3, 4, 5, 6 terms. So using this you can write the expansion of a plus b raised to power 5 also orally. In multiplying a plus b 5 times we will take say about 1.5 minutes time, but using this Pascal's triangle you can write this verbally. We start from a5, a4, a cube, a square, a and no a. From here we start with b5, b4, b cube, b square, b and no b. Then write the coefficients 1, 5, 10, 10, 5, 1, 1, 5, 10, 10, 5 and 1, and just put positive signs in between all terms. This gives us the expansion of a plus b raised to power 5, which we can find in just a matter of 10 seconds. Now using this a plus b whole cube and a minus b whole cube, we have alternative positive and negative sign here. So this is the expansion of a minus b whole cube. So now we use these two expansions to derive some more algebraic identities. The first thing which we are going to derive is from this one. What we do is we retain these two terms on one side, that is a cube plus b cube, and the remaining two terms we shift this side. A plus b whole cube is already existing on the left hand side. We shift these two terms here, so the sign changes, and now we can take minus 3ab common, which leaves us a plus b as a factor. This is the identity for a cube plus b cube, the first identity which we are dealing with in trick 12. From this we can arrive at one more result, a cube plus b cube. You can take a plus b common. What we are left with is a plus b whole square minus 3ab. and when you open this whole square, let me just remove this, and now you can open this whole square, a square plus 2ab plus b square minus 3ab. So we arrive at one more identity of a cube plus b cube, which is a square minus ab plus b square as the second factor. So this is the second identity which we keep on learning in class 8th, class 9th, class 10th, and still we get confused in these identities. Similarly, if you use a minus b whole cube, you can derive the formula for a cube minus b cube also. Let me just demonstrate. We have a minus b whole cube as a cube minus 3a square b plus 3ab square minus b cube. Now we need to find a cube minus b cube. So we retain a cube minus b cube on one side, and the other side we have a minus b whole cube. These two terms you can shift this side, the sign changes, and now you can take common to arrive at the formula of a cube minus b cube, which is a minus b whole cube plus 3ab a minus b. This is the first identity of a cube minus b cube. Now if you take a minus b common here, you can find out one more identity in factor form. A minus b is common, so we are left with a minus b whole square plus 3ab. So when you expand this, you have one more identity. A cube minus b cube is a minus b a square plus ab plus b square, which is the fourth identity we are looking for. So you can see that just by utilizing small concepts of Pascal triangle and decreasing powers of a and increasing powers of b, you can find out all the expansions like this, and from these expansions you can arrive at other identities like a cube plus b cube and a cube minus b cube also. So students, with little practice you can remember these identities for life, but if you cram these identities, you are bound to go wrong somewhere or the other. So keep learning, keep enjoying, share and subscribe the videos if you like.